So today we are from group number 8. We would like to present a project report about grid connected PV system location at Syria and Malaysia that we have complete. So first of all, I would like Ashraf HASBI will explain our project introduction.
My name is Ashraf bin HASBI. For the introduction is photovoltaic system are the most promising renewable energy source in Malaysia due to its abundant solar irradiation. The Malaysian government has launched various renewable energy programs to encourage the use of PV system. Most of the PV system are single phase and the installation is customer driven. Therefore, the growth of PV system in low voltage distribution network has the potential to raise several technical issues, including voltage rise and voltage unbalance. A grid-connected photovoltaic system or grid-connected PV system is an electricity generating solar PV power system that is connected to the utility grid. A grid-connected PV system consists of solar panels, one or several inverter, a power conditioning unit, and grid connection equipment. They range from small residential and commercial rooftop system to large utility-scale solar power station. Unlike standalone power system, a grid-connected system rarely includes an integrated battery solution, as they are still very expensive. When conditions are right, the grid-connected PV system supplies the excess power and beyond consumption by the connected load to the utility grid.
Hello, my name is ARIF bin Adam. So I will continue based on simulation. I will explain about system analysis. So the cost PV grid connected at Malaysia and Syria, 3.1. To build a grid-connected PV system requires several tools including converter, grid, and even PV. So here we present some costs that we need to be taken into consideration to build a grid-connected PV system. So the first thing, cost converter. Both countries have same price US dollar. The countries is Malaysia and Syria. So we taken this from Alibaba.com, researching from Google. Then the cost medium voltage peak and off-peak commercial tariff. In Malaysia have peak and off-peak period, which is peak is from 8 am until 10 pm and off-peak from 10 pm until 8 am. For the details, we can find through this link from TMB. Then next, so the price for 1 kilowatt per hour for peak period is 36 cents in Malaysia or 0.09 cents in US dollar. For the off-peak period is 22 cents Malaysia or 0.05 cents after convert to US dollar. So this is a detail we can prove start from about 4 hours. Night time zone start after end of the peak time for 8 hours. So the cost PV array, the price of PV array installation cost at Malaysia is between 16,000 to 23,000 ringgit for a 3 kilowatt based system. But this is just a standard residential installation, different from 4 kilowatt to 12 kilowatt. So what we converted from 23,000 ringgit to US dollar with a value of 5,698 US dollar. So for the price of a 4 kilowatt PV array, so the price of 1 kilowatt is equivalent to 1,424 US dollar. And this is a researchable link from the cost PV so that is doing. So this the picture are from our research, and the average solar panel cost in Syria VA is around $2.86. Given a solar panel system size of 5 kilowatt and average solar installation in Syria, VA range costs from $2 to $3 with the average gross price for solar in Syria, VA coming in at 40,300 US dollar. That's all.
Okay, thank you Akmal. So for my part, I will explain about solar resort data, Kuala Lumpur, Malaysia. This is information about the solar radiation that available at power system of Kuala Lumpur, Malaysia. The location latitude is 3 degree 8 minutes in north, and location longitude is 101 degree 42 minutes in east. At the solar resource graph, daily radiation will display as bar graph, but for clearness index value will display as line graph. As we can observe, the highest daily radiation is at April, which is 5.330 kilowatt per day, while the lowest daily radiation is at December, which is 3.770 kilowatt per m square per day. The average of daily radiation is 4.797 kilowatt per m square per day. Next, for the clearness index, Homer will calculate it based on measurement of the clearness or cloudiness of the atmosphere. As you can see, the highest clearness index is at April, which is 0.516, and the lowest one is at December, which is 0.6. The average of clearness index is 0.480. Next, Damascus, Syria. This is information about the solar radiation that available at power system of Damascus, Syria. The location latitude is 33 degree 30 minutes at north, and location longitude is 36 degree 90 minutes east. At the solar resource graph, daily radiation will display as bar graph, but for clearness index value will display as line graph. Highest daily radiation is at June, which is 7.500 kilowatt per m square per day, while the lowest daily radiation is at December, is 0.090 kilowatt per m square per day. The average of daily radiation is 4.836 kilowatt hour per m square per day. Next, for the clearness index, Homer will calculate it based on measurement of the clearness or cloudiness of the atmosphere. As you can see, the highest clearness index is at June, which is 0.652, and the lowest one is at December, which is 0.4. The average of clearness index is 0.572. And next, Muhammad Hassan will explain optimization result.
Okay, thank you for Farhan. I will continue. My name is Muhammad Hassan bin SHAFIE. Okay, optimization result for Kuala Lumpur, Malaysia. Okay, this is the result for home simulation software offered by use in Kuala Lumpur, Malaysia. This show total MPC is increasing order, which the first one is $32,290 and followers by $41,830. Net for the last call for each the two system type of this search space is $0.113 per kilowatt, followed by $0.141 per kilowatt. Holmes has determined the show not adding any VC to the system reduce the total of MPC and the cost of energy. Okay, Damascus, Syria. DE result for the home simulation software optimize by use in Damascus, Syria. This show total MPC is increasing order, which the first one is $28,860 and followed by $46,940. Net for the less cost of the is the two system type of this search space is $0.101 per kilowatt, followed by $0.155 per kilowatt. Homers were determined that show not adding any VC to the system reduce the total of MPC and the cost of energy. Okay, next simulation result. Okay, this was the first pie graph for Kuala Lumpur, Malaysia. The first pie graph show that the cost of converter represent last proportion 55% of the total capital cost of the system. Since the PV price is increases, the cost of system V is sensitive to the size of PV. Total MPC is $41,830, which for levelizers cost of energy is $0.141 per kilowatt. Net is OMM, which is $2,420 per year, and for total annualizer is $3.271 per year. Then, as we can observe, Home chose a system with 4K watt for VC as the less cost system that can be used. Okay, Damascus, Syria. The pie graph show that the cost of converter represent last proposition 70% of the total capital cost of the system. Since the PV price is increases, the cost of system will be sensitive to the size of PV. Total MPC is $46,940 with of levelizers cost energy is $0.155 per kilowatt. Net of NM review is $2,368 per year, and for the total annualizers is $3,670 per year. Then, as we can observe, Home chose a system with 4K watt of PV as a less cost system that can be used. Okay, I leave it to my friend SHAFIQAH to continue.
Okay, thank you to all my fellow friends. For discussion and conclusion, this mini project is called the Grid Connection PV System in two countries, which are Syria and our country, Malaysia. We knew that PV system are the most promising renewable energy source in Malaysia due to its abundant solar irradiation. A grid PV system is an electricity generating solar PV power system that is connected to the utility grid like diesel generator or wind turbines. It is consists of some component like converter and PV array, etc. Okay. Based on our survey and observation, for the result and analysis, the total of NPC for Damascus, Syria is $46,914, while at our country, Kuala Lumpur, Malaysia, is $41,813. Next, the levelized cost of energy for Damascus, Syria is $0.155 kilowatt, while $0.141 kilowatt for Kuala Lumpur, Malaysia. That means the total of NPC and levelized cost of energy at Kuala Lumpur, Malaysia is higher than Damascus, Syria because of several factors. Okay, firstly, it is because the distribution of sunlight at Damascus, Syria is less frequent when compared to Kuala Lumpur, Malaysia. The position of Malaysia in the equatorial plane be the causes of sunlight to always be received throughout the year, especially at Kuala Lumpur, Malaysia. It is different to the situation at Damascus, Syria, where winter begins in December till February. This country receives the least amount of sunlight because of each 3 months changing weather. After spring, the weather changed to summer. That is why at June, July, and August, they receive the maximum amount of sunlight in the year. The total of reception of sunlight in Damascus will begin to decline after the end of summer and continue in September until November. In the nutshell, we already know that an optimal design is based on technical sizing. For grid-connected PV system can be presented by this technical report. We are able to understand that to achieve an efficient product, we need to understand the energy cost and energy production. We need to study some new things like the PV system on how it works, where the sunlight is needed to be changed to electrical energy. By comparing users at different countries, we can conclude that our country, Malaysia, is better when it comes to use PV system compared to Syria. The main factor is because Malaysia receive higher amount of sunlight because of its strategic place, which is on the equatorial plane. In Malay, we can call it as Garisan Khatulistiwa. We are using Homer, which is a software to simulate, learn, and determine the efficiency of PV system. Therefore, this is a great discovery for a different resource for better life than only depending to non-renewable energy source. Thank you.
Okay, so that's all our present project report for today. All of us already explained our parts in this technical project. So lastly, I would like to say thank you to my group members because quite good cooperation. And we also like to say thank you to Madam Rohena because already guide and explain about this mini project. So yeah, thank you and Assalamualaikum. Bye.
Thank you. Waalaikumsalam.